Good morning. We are starting Chapter 6, Systems of Equations. Please get out your packet so that we can take Lesson 6.1 notes. For systems of equations, there are three methods for solving systems: graphing, substitution, and elimination. We're going to talk about graphing today. We're going to start by practicing rewriting in standard form, or from standard form to slope-intercept form, and then graph it. So standard form is ax plus by equals c, versus slope-intercept form is y equals mx plus b. So that's what we want our answer to look like, is y equals. Okay? So first step is we want to move the x to the other side. So you're going to subtract 8x from both sides. That leaves you with negative 4y equals, put the x first, negative 8x, and then it's a positive 24. Now get rid of the negative 4, so divide everything by negative 4. You get y equals, negative 8 divided by negative 4 would be a positive 2x, and 24 divided by negative 4 would be a negative 6. So now, looking at this equation, my slope is the first number, 2, and we're going to put it over 1, make it a fraction, and my y-intercept, or the b, is the number at the end, negative 6, which is a point, 0, negative 6. So we're going to graph 0, negative 6, which is down here, and we're going to do our slope, which, because it's positive, is up, and the bottom number is always right. So from here, up 2, to the right 1, up 2, to the right 1. You can keep going as many times as you want. Connect your dots. There's your line. Okay, so we're going to do the same thing on the next two. We want to move the x over, so subtract 3x. Negative 2y equals, put the x first, negative 3x plus 12. Now get rid of the negative 2, divide everything by negative 2. So y equals, a negative and a negative becomes a positive, and we're not going to reduce, or you can't reduce 3 over 2, so you just leave it as a fraction. Okay, and then 12 divided by negative 2 is negative 6. So now, my slope is that 3 over 2, which is already a fraction, and my b is negative 6, which is 0, negative 6. So graph that, and this time, this is telling me to go up and to the right. So up, 1, 2, 3, to the right, 2. Up, 1, 2, 3, to the right, 2. There is your line. Hopefully this is all familiar because we have done this before, it's just been a while. Last one here at the top, subtract 9x from both sides. 5y equals, again, put the x first, plus 35. Divide everything by 5. So you're left with y equals, negative 9 over 5, we can't reduce that, so just leave it. And then 35 divided by 5 is 7. So my slope is negative 9 over 5, and my b is 7, or 0, 7. So graph 0, 7, which would go off the graph right there. And then we're going to go down, because it's negative, and to the right. So down 9. So here's down 7, 8, 9, and then over 1, 2, 3, 4, 5. You can only put 1 point here and connect those. Okay, so that's just review on how to graph. That's not actually systems because there's only one equation. Okay, a system of equation has two equations. So let's talk about our different methods here. Which method is best? So we have graphing, substitution, and then elimination, two different versions of it. So for graphing, you would use this whenever you have y equals mx plus b, because that's pretty simple to do, because you can graph it if it's already written that way, but you might not end up getting an exact answer, because sometimes you can't tell where the two graphs intersect, which is what you're looking for, is where they intersect. For substitution, if one equation says y equals or x equals, then you can substitute the value into the other equation. So this works really good, especially if you have an x equals, because if you have a y equals, you might graph it, but if you have an x equals or y equals, then you can substitute. For adding with elimination, if you have one variable that is the opposite of the other, meaning one's positive, one's negative, so like you could have a positive 3x and a negative 3x, this would work really well because those would cancel. And I would only use elimination with multiplication if none of the other above work, because you're going to have to multiply by a value to create these opposites. Okay, flip the page. So, graphing, like I said a second ago. First, a system of linear equations is when you have two or more linear equations working together. So you're looking at two equations at the same time. Their solution is where they intersect, and it's a coordinate, x, y. Okay? Three different scenarios here. When you graph and they intersect at one point like this, the number of solutions is you have 1, and this is called consistent and independent, both. Okay? And a clue to tell you by looking at just the graphs would be they have different slopes. Okay? One could be a slope of 2, one could be a slope of 3. Whatever it is, doesn't matter, but they're different. Okay. When you graph your two lines and you end up getting the same line. So I'm going to make a little note here. You get the same line, as in they end up overlapping one another. Same line. You get infinitely many solutions. So infinitely many solutions. I guess if you want to put one solution, you could add the word solution. Okay? This is called consistent and dependent, and how you can tell, your clue would be they're going to have the exact same slope and the same y-intercept. Okay? And then the last scenario is you get what's called parallel lines. Parallel lines never intersect, so you have 0 or no solutions. 0 or no solutions. This one's called inconsistent, and you can tell because they have the same slope, but they do not have the same y-intercept, so only the same slope. Okay, so let's try graphing some of them. Best scenario is to put them in slope-intercept form, find the slope and y-intercept like we were just doing on that last one. So, two separate ones. We're just going to graph them on the same graph. For my first problem, my slope is negative 3 over 2, and my b is 3, so that is 0, 3. So graph 0, 3, and go down 3 to the right 2. I'm going to do it one more time. Down 3 to the right 2. Draw that line. So here's my first one. Second one, I have a slope of 1/2, and my b is negative 1. So that would be 0, negative 1. So 0, negative 1 is down here, and go up 1 to the right 2. Right there, up 1 to the right 2. So these lines intersect. It's like the very first scenario, and I have one solution. I have the answer of wherever they intersect at, and that coordinate is 2, 0. So that's my solution. That's my final answer. Okay, so let's do the exact same thing for the next one. My m is 2 over 1. My b is 3, which is 0, 3. So graph 0, 3, and go up 2 to the right 1. Okay, that's going off, so let's go down 2, back 1. Down 2, back 1, down 2, back 1. Just so we get a better line. Okay, that second equation doesn't say y equals. So we have to make it a y equals, just like we did on the first page of your notes. So I'm going to subtract 8x from both sides. Negative 4y equals negative 8x minus 12. And then I'm going to divide everything by negative 4. So y equals positive 2x and a positive 3. So my slope is 2 over 1. My b is 3, so that's 0, 3. So 0, 3, 1, 2, 3 is right there. And then I'm going up 1, 2 over 1. It's the same line. So it's not just one point, it's the exact same line. And if I look, this equation and this equation are the same. So your answer is infinitely solutions. Infinitely many solutions. And if you'll make yourself a note, same line. Okay, last one. We have to rewrite both of them. Subtract x. I'm going to make it a 1x. So negative 2y equals negative 1x plus 4. Divide by negative 2. Y equals, this becomes a positive 1/2 x, and this is a negative 2. So my slope is 1/2. My b is negative 2. So 0, negative 2. 0, negative 2 is down here. Up 1 to the right 2. Up 1 to the right 2. Second one, subtract x. We get negative 2y equals, I'm going to make it a negative 1x minus 2. Divide everything by negative 2. Y equals a positive 1/2 and a positive 1. So my slope is 1/2 and my b is 1. So 0, 1. 0, 1's up here. Up 1 over 2. Up 1 over 2. We get parallel lines. And parallel lines never intersect, so my answer is a no solution. Okay, that's it, guys. Check Google Classroom for your assignment.